Hello, hello, hello. What ho? Welcome back to another exciting adventure of the plain truth. Also, Radio Free Anarchy, but this is more the plain truth because of the research that is involved. And I'm reading about mirages from Andrew Thomas Young. And there's been a lot of interesting information, but at the same time, the information is, I don't think, very clear who don't know anything about this research. But because if you haven't seen a lot of what you can read about in here, like I've seen the things that are being described, so I can reimagine. But if you haven't ever seen it or care to think about it, a lot of this is a bit abstract. But I guess what I wanted to try to express is where I'm at in this article. I've formulated this response to his criticism that one of the researchers was assuming something he hadn't proven, right? If this happens, then this is the cause. I see this happen, therefore the cause is what I said it was, right? That's assuming the consequent or begging the question. And he has a criticism. He says this guy creates or commits a formal logical fallacy. Except for the fact that Andrew Thomas Young, ironically, is creating his own fallacy by doing the same thing, by inserting in the interpretation of what a mirage is, the Earth's curvature as the cause. It's just, so, I mean, look, you got to read this stuff with more than just a critical, caustic attitude against people who don't believe the mainstream media about the shape of the environment in which we find ourselves. Okay, so he's talking about this guy named Voltman, and he's trying to understand the movement of the horizon. And in an important defining moment, the horizon is the dividing line of your line of sight in front of you. Okay? Horizon is a Greek word which means division. So the horizon divides the ceiling and the floor. This is perspective. If you're an art student or if you know someone, talk to them about what perspective means. It's convergence of just our entire, whatever, 172 degree, whatever it is. Like I'm looking out in front of me and everything is converging into a single point in front of me that is not, I don't look down to it, I don't look up to it, I look out to it, and there it is in front of me. And it's always that division is just the convergence of distance to a fine point beyond my ability to see that far. What limits our ability to see? That's the question. What is it that limits our ability to see things in the distance? That's the question. So this guy puts up these two markers and has something between them, and he's watching it move up and down, right? Okay, that's the basic idea. And it says, he found the terrestrial refraction greatest in the morning and lowest in the evening, with a total range over 10 arc minutes. And, I have no idea how large or small that area would be, but 10 arc minutes. You see this, like it's measurable that this thing is changing its position. The measurements showed that heat has the strongest effect of all the variables. If the water is 2 or more Fahrenheit degrees warmer than the air, the rays passing over the water are always depressed, okay? I think that that's a very important distinction to be making, because in a moment we're going to see that Andrew Thomas Young employs assumptions about what light is doing, but we're looking at something that obviously is lower than it was. That's what it means by depressed. It's lower. But you had to have had an observation beforehand to compare it to, right? The rays passing over the water are always depressed, but raised, that is the rays of light, are raised if the air is 2 degrees or more warmer than the water. Among more than 150 observations, this rule has not a single exception. I find that very, very extraordinary and fascinating. Because this is a very old research, like the 18th century, the late 18th century. These observations are being made. Like, how did he measure the? You know what I'm saying? Like, all you can do is measure your air here. Who was measuring? Like, that's my question. Like, okay, you have this information. You say that there's no exception, but who was measuring the entire corridor? Or did you just assume that it was uniform throughout the entire because of where your area was? You're like, I don't have anybody out there measuring anything. All I can do is where I'm at. I'm just, this is stuff that I don't have to read about this because I've existed in this research on the field myself. Okay, so let's see. Did I move it? Oh, there it is. Okay, yeah. So among more than 150 observations, this rule has not a single exception. I find that extraordinary and amazing, and I challenge it. His measurements showed that this mirage is always accompanied by depression of the apparent horizon. Okay? I don't know what these people mean by these terms. I can imagine because I've seen what they're talking about. But you only know there's a depression when you have a standard against which to hold that movement. Otherwise, when you look out, it's just right there. It's too far away from your naked eye for you to even see that there's a mirage at times. You just see something that's so small, and I know that there's a house there or whatever, so that's the house. But you don't know that the house is a little bit larger, apparently, because there's an inverted image below it, which extends or depresses the position of what we would call the horizon. And by that I mean, and I should probably show pictures along this point to give you guys visuals, but unless you have land in the distance that is the elevation of the horizon in front of you, like right there, right? So just pretend like I'm showing you a picture, and this is the top of the mountain, right? But then below it there is this thing going on that looks like water, or it looks like a mirage or a mirrored image of this or whatever. Like, you can tell that there's something else going on. Like, what is that? What's your explanation for that? So here's the top of the mountain. That's the horizon. Out that far, right? The top of the mountain is what is dividing the sky from terra firma, right? You're coming at that point. You're never going to see higher than this point. This is the highest point, no matter how far away it gets, right? So then they're talking about the horizon below the horizon. Here's a horizon, but we see a second horizon kind of like here, And I'd have to show you what I mean by that, but it looks different on land, it looks different on the ocean. So you have a similarity, but you also have a difference, and then you have to understand how those things are coming together. I hope this is interesting. I was just talking to myself out loud reading this thing anyway. I'm like, I might as well start just recording what I'm saying because I found it helpful for me to try to work through what I'm like. Right? So, his measurements showed that this mirage is always accompanied by a depression of the apparent horizon. And again, they haven't defined this term. Like, I need to know what this, because if you're looking out at the ocean, there's no apparent horizon. It's right there. It's where the water stops and the sky starts, or it's where the sky stops and the water starts. However you want to look at it, that point is the horizon. There's no apparent anything about it. Unless you start to notice that it changes its apparent location. And what does that mean? It gets closer to you. That's kind of weird, don't you think? It gets farther away from you. That's kind of weird, don't you think? And those two images that you see when it's near and far, near doesn't look the same as it does when it's far, right? They don't look the same. The only thing that ever changes the apparent target's image, right? You see a target in the distance. It's a ship, it's an island, it's a boat, it's a mountain, whatever. The only thing that ever changes the way that looks is that medium through which you are looking. What is it that exists between your nose and the target? What is the only thing that exists between your nose and the target? What is that environment called? Air, the atmosphere, the ether band. That's your only variable besides your position between you and your position in relation to the target. If you raise your elevation, it's not going to look the same. In the same thing, you build a contraption where you can go up 10 stories or whatever, right? And you're making an observation on the ground level. Look at what this target looks like. And then you slowly raise yourself up and you keep the eye of the camera on that thing. It is going to change every frame, every single second. It is going to go, or it's going to go, and it's going to be like this kaleidoscopic menagerie of colorful refraction, you know? All right. His measurements showed that this mirage is always accompanied by a depression of the apparent horizon. And again, I mean, they would have to explain what that means, because in order for you to say something is depressed, it has to have a 0 point, because it's in the negative, right? That's what depression means. You're in the negative, right? So they're saying these things, but they're not explaining, and then they're all just assuming things because they grow up in the same environment, assumption. And so then it says also that the mirage is always accompanied by an inverted image that is appreciably smaller than the erect one. I don't like that word smaller because it makes it sound as though it's tapered, you know? So you have this target here, and then below it is the image, but it's smaller. Like, that's not the way the mirage works. The mirage is symmetrical. It is symmetrical. The smaller part has to do with how much of the target is reflected in the mirage. So I would probably rather say the inverted image was always only a certain percentage of the physical target. And by the way, they don't make this caveat in parentheses, but I'll make it. Sometimes you can get the entire image inverted. So you'll see it. This is the difference between when it touches the horizon and when it's floating above the horizon. And that becomes this, here's the horizon and here's your target above the horizon. What's right here? It's the air, right? You just see this target in the air. So then imagine you're this guy back in the 1800s and you're able to like use a telescope and look at shit with your eyes that you couldn't see, with your naked eye. And you're like, what am I looking at? Like, what am I seeing? Like, this stuff is just changing constantly. Why? Because you're looking through a medium that is the only thing between the nose of your face or the extension of the lens of the telescope that you're using. What is it that exists? Like, can you see that thing? Yes, I can see that thing. That means there's nothing else between you and the thing because you can see the thing? Yes, that's correct. You know what I'm saying? Like, I'm spelling this out. If you can see my hand in its entirety, there is nothing between my hand and you. It is unobstructed. And if I take this back and take this back and take this back, you're going to see it change every single frame of your eye. And the reason I think is how air works. Air is a liquid fluid gas. I mean, it's so minute in its particulates, but it's water. I'm breathing water. Water. We live underwater. We live within an environment that is a lens between our eyes and the target. So if you can see the target, I see the target, but it doesn't look the way I thought it would. Well, how should it look? What did you think it was going to look like? Well, it looks like there's two of them, but the one is upside down underneath the other one. Yeah, what is that? Like, how would you start to explain all of that stuff? And then, if you had that contraption where you could raise you have something that's out there in the distance that is in a mirage, right? And then you get into this elevator and you go up, how is that going to change?